In the previous video, we introduced the concepts and syntax of the DOM, nodes and properties and methods for the document type node, the element type node, and text type nodes. But our examples were pretty minimal. In this video, we demonstrate some ways to apply this information to real web pages. And although our examples are somewhat simplistic, we hope you'll be inspired to think of your own applications. The key to effective use of DOM with JavaScript is planning. Map out exactly what you want to have happen, then convert that in your mind to small steps using DOM methods and properties in a JavaScript event handler. Here's an example. Suppose we want to create a virtual keyboard, provide letters and numbers and punctuation and so on, so that the user can click on each character and that character will be captured and put on the screen so they can see what's being entered. Now, in a later lesson, we cover forms and input elements, but for now, we'll use the tools we have. We'll just do some representative characters, not the whole keyboard character set. To start, how can we represent the input characters? I'm thinking something simple, maybe. So I can tell we want a monospace font and a border around each character. That tells me we should use a style rule like this. Fixed, font family courier, font weight bold. So let's start with a paragraph, class equals fixed, A, B, C, D, E, F, and this displays this way. How to get the little boxes around each character? One simple solution is to create another style rule, letter, with a red border, and span each character separately. So let's try this style rule. Letter, border is red solid 2 pixels. And now our paragraph element becomes more complex. Class equals fixed, span, class equals letter, A, end span, and so on for the first 6 letters. Notice that putting each letter on a separate line in the HTML will make it easier to introduce changes down the road. And this displays this way. The letters look cramped. Let's fix that. A little padding should do the trick. So change the letter class to be border red solid 2 pixels, padding 2 pixels. And now we see, okay, that's a little nicer. Feel free to play with that. Now, it might help the user to get an indication of what to do. So maybe add this text, which then displays this way. Might be better if the keypad letters, for there will be more, started on a new line. So now we get this, yielding this display. Yikes, the lines are practically on top of each other. 2 possible fixes. 1, use the line height style property, but we haven't introduced that yet, so not fair perhaps. Or 2, add another BR element. Let's do that. Giving, very nice. Now, we need a target for the letters to go to when the user clicks on them. The instruction says, see them in the following paragraph, so let's add a paragraph. Now, this paragraph will, of course, be an element node, and we'll be accessing it from our first paragraph, so it needs an ID. Maybe P ID equals out and P. Notice I put a single regular space. This doesn't seem to work if I don't, so I do. Now, here's where you need to think it through. When the user clicks a letter, that letter needs to be added to the paragraph with ID of out, which might suggest we'll be using document.getElementById out, and we will. But remember, this is an element node, and it's the text content we want to modify. If you think about it for a while, you'll see that the text content has to be the first child node of the paragraph element. So document.getElementById out.firstChild. And what we want to do is to append the related character to that text node when the user clicks that letter. So for example, the first letter entry now becomes this: span class equals letter on click equals document dot get element by ID out dot first child dot append data A, and then the content A. And continuing along that line, we see this code. Now this displays the same as before, but when the user clicks any of these letters, the letter then displays in the following paragraph. Take a look. So we click on F, and then A, and then C, and then E, and it all shows up in our next paragraph. Okay, and you can easily see how to add more letters and numbers and so on. But it would be nice to allow the user to insert spaces between words. Well, we can add a space key, like this. And clicking the SPC spot inserts a space, as shown here. So we click F, A, C, E, and then space, and D, E, E, D. Kind of nonsense just to demonstrate. Let's take it one more step. Let's provide the ability for the user to fix a data entry error by backspacing a character. This requires two things on our part. First, code a key representing the backspace. That's pretty easy. And second, in the on-click event handler for that key, delete the rightmost letter in the target paragraph. Well, that's a little trickier. Now you may recall that the method to use is delete data, and this method takes two arguments: the place to begin deleting and the number of characters to delete. Well, the number of characters to delete is easy, 1. But how to figure out where to start? Well, we want the last character to be deleted, and we have the length property available. The length specifies the number of characters currently in the text node. But for text nodes, we start counting at 0, not 1. So we need to delete the character at location or offset of length -1. This means we'll want to have two steps in our on-click event handler. One, calculate the offset, put it into a variable, and then invoke the delete data method on the text node. So this reasoning gives us this, which displays this way, and we see the demo. So we enter F, A, D, E, oh wait, backspace, backspace, C, E. That's what I'm after. So you see the process. Decide how you want things to behave, then break it down into simple elementary steps. Get the order of the steps right, code it up, and test. Let's look at another example. Sometimes you want an image or block of text to show, while at other times you may want it to be hidden. Let's give that a try. Set up an image element and a couple of paragraphs that could be clicked to show or hide the image. So first, we'll put in an image. Image ID equals pic, source equals bugmove.gif, alt equals moving GIF image. Then we can add one paragraph to set the hidden attribute and another to remove it. Since hidden is a Boolean, to do the set, we simply code hidden for both inputs to the set attribute method. The result might look like this. Paragraph on click equals document.getElementById pic set attribute hidden, hidden. Click this line to make the image disappear. And then there's our image. And then after that, another paragraph on click equals document.getElementById pic remove attribute hidden. Click this line to make the above image reappear. And here's a video of this working. Here's the display of our code, and now we'll click this and the image disappears, and we'll click this and it reappears. For our last demonstration, let's work with lists. Suppose we have a list of available courses and we need to choose 3 for this semester at the Flying Drones Academy. What we want to do is click on a course in the available course list and have that list added to our course schedule list. So we start with 2 lists available courses with all the courses we're considering, and course schedule, initially an empty list. Since we will be adding courses to the second list, we know we have to have an ID value, so we start with this. Available courses, unordered list, and then there's 5 courses listed as elements or items in the list. And then course schedule, unordered list, ID equals header, so we'll refer to that later. It displays rather simply. Now, my first approach was this. When a user clicks on a course, we'll build an LI element, then create a text node with the course info, then append the text node to the LI element, then append the result to the course schedule list. So here goes. In available courses, here's my unordered list, and I have a list item. OnClick equals F200 equals document.createElement LI. So now I've got my LI element, and it's called F200. And then I assign the string to txt, document.createTextNode, quote, F200-fuel systems. And then I append that text node to the LI element. And then document.getElementById header append child F200 appends the list element we've just created to our schedule list. And all that is in the LI definition, and we finish it off with the text F200 fuel systems LI. And it turns out it works like a champ. But then I got to thinking, well, we're starting with an LI element in the first list and copying that element into the second list. Maybe we can simplify the process. So I thought it through and came up with this. List item onClick equals document.getElementById header append child this. And then the text for my list item. And it works too, like a champ. Except for one little thing. The LI element, using the simpler approach, actually ends up moving itself into the course schedule list, totally removing it from the first list. Maybe not a desired end. Well, if we take it off the courses available list and move it to the course schedule list, then it can't be copied over twice. Whereas using the first technique, I can actually copy the selected course any number of times. Maybe that's what I want to avoid. Trade-offs. We can fix either behavior once we get some more JavaScript tools. For now, understand how these two alternatives behave. So here's our 2 course lists, the first of available courses and the second of our schedule. On the first entry in the available courses is using the first technique, and if I click there, it copies it to my course schedule. The second course, I'm trying that second alternative, and I click there. It moves it down to the course schedule, but removes it from available courses, so I can't click it again. Whereas the F200 course, I can add it as many times as I want. Stepping back just a bit, we find the concept of the window object as a natural extension of our work so far. The window object is the root object of what is provided by a browser. A document can be considered to be a sub-object of the window object. Conversely, since a document is displayed in a window, the document can be considered to be a property of a window. Just as a document consists of a collection of components, nodes, a window has a set of components, shown here in this little diagram. In JavaScript, you can refer to the window by using either of the terms window or self, or omit a base reference and it is implicitly window. So window.document, self.document, and document all refer to the current document in the window where the script is running. There are 3 Windows methods you might want to use in JavaScript. Alert, passing a string expression, displays the expression in a pop-up window that also has an OK button. Clicking on the OK button will remove the pop-up window. Confirm is passed a string expression, and it displays that expression in a pop-up window that also has an OK button and a cancel button. If the user clicks on OK, the window is removed and the method returns a true value. If the user clicks on cancel, the window is removed and the method returns a false value. And prompt, again, pass a string expression. It displays the expression in a pop-up window that also contains an OK button, a cancel button, and a text entry field. If the user clicks OK, the window is removed and any text in the input field is returned as the method's value. If the user clicks cancel, the window is removed and a null string is returned regardless of any text the user may have entered. For now, we focus on alert, which is a useful tool for displaying footprints, where you are in the code, and breadcrumbs, the value of variables at this point, for the testing debugging process. Example, window.alert. In P3 event handler, the value in more is plus more, or equivalently alert with the same content. We'll discuss confirm and prompt in later sessions. In this session, we've demonstrated some applications for using the DOM and JavaScript, and we've introduced the window object and the alert method. In the next lesson, we expand our repertoire of JavaScript. See you there.